Hey guys, so in 7.4, we're going to be working with equations that are in quadratic form but don't look like it, okay? So what we have to do is we have to make a simple substitution, basically one little step that'll help us get to the place where we could factor or use the quadratic formula or complete the square or whatever we need to do. So if you look at this first equation, okay, we have an x term at the beginning and then a root x is our middle term, right? It's all set up. It looks a lot like the quadratic formula, but it's or quadratic equation, but it's not. Okay, so what we need to do is we need to substitute something in for root x. Okay, so we're going to look at this middle term is always what we're going to do the substitution for. Right? I'm going to use u. You could use whatever, obviously whatever variable you want. Okay, so u equals root x. Right? So if I'm going to substitute u in for root x, this equation is going to turn into u squared minus 5u plus x equals 0. Right? Because if u is root x, then u squared is going to be just x. Okay, so now you see that this is something we can very easily factor. So u minus 3 times u minus 2 equals 0. Okay, now once you get to this point, the only reason we do this u substitution is so we can factor, right? So we could see the factoring. Once that's done, we could pick up our original variable and plug it back in, because remember, we don't want to solve for u, we want to solve for x. Alright, so as quickly as you can, get that x back in there. So we've got two possible answers. Root x equals 3, or root x equals 2. Okay, so x equals 9, or x equals 4. Now remember to plug these back in to the original equation, right? Because we've got a square root in, or a square root of a variable, right? We have to check for extraneous roots. When you check this, you're going to see that 9 minus 15 plus 6 equals 0. That's fine. 4 minus, let's see, 4 minus 10 plus 6 equals 0, so they're both good. It all works out, right? But just check. Second one, right, very, very similar. The only difference is we've got a 2x and a root 2x instead of x. Okay, so we're going to substitute in u for root 2x. Remember, you're always substituting in for the middle term because when you square it, then you get that squared term. So u squared plus 2u minus 15 equals 0. Notice it's not a 2u squared up in front because we're substituting u in for 2x. So 2x squared is going to be u squared, which is the same as 2x. Right? Once again, I got another easy one that we can just factor. So y, or u plus 5 and u minus 3 equals 0. Now let's get that 2x, root 2x, back in here. So we've got root 2x equals negative 5, or root 2x equals 3. Okay, so they're going to have, when you solve these, x equals 25 over 4. Nope, 2. That's wrong. Very wrong. Shoot. Just scratch that out. X equals 25 over 2. And on the right here, x equals 9 over 2. Okay? Remember, we have to plug these both back in to make sure they work. When you plug in the 25 over 2, it's actually going to be 25 plus 10 minus 15, which is not 0, so that one's not going to work. The 9 over 2 does work, because we'll have 9 plus 6 minus 15 equals 0, so that one does work. That's the only answer. Now, number 3, okay, 3 gets a little bit more tricky because you're going to also use it. Basically negative exponents. This is the best way to handle this one. So what we're going to do is we're going to make this 6u to the negative 1 power minus 17u to the negative 1/2 power, because remember, square root of u is like 1/2, and it's still in the denominator, so it's negative 1/2. Bring the 5 over, equals 0. Alright? So since I've already got u in here, we have to use a different variable. Alright, so let's make it a equals the middle term, u to the negative 1/2. Alright, so we have, now u and a kind of look similar. That's dumb on my part. Alright, so we have 6a squared minus 17a plus 5 equals 0. This one factors as well. 3a minus 1 and 2a minus 5 equals 0. Okay, now we got to get that u to the negative 1/2 back in. I'm going to use it as 1 over square root of u, because I think that's easier to solve for. So we've got 3 over square root of u. Okay, so 3a is the same as 3u to the negative 1/2, which is the same as 3 over square root of u. And that's equal to 1. or 2 over square root of u equals 5. Alright, now you can solve both of these equations by multiplying the square root of u over and then squaring both sides. So u equals 9 or u equals 4 over 25. Alright, you can plug both of those in to see if they work. The 9 will work. Yes. Because you get 2/3 minus 17/3 equals -5. That's good. And for the 4 over 25, you have, let's see, we're going to get 75 halves minus 85 halves equals -5. That's good too. So they both work. Probably should check if you calculated with something difficult like that, but it does come out. Last one on this side is probably the easiest and most common thing that you will see with these u substitutions or any quadratic substitutions. Okay, we've got the x squared in the middle, and we've got x to the 4th as basically our x squared term. Okay, so u equals x squared. So if u squared minus 9u plus 8 equals 0. So u minus 8, u minus 1 equals 0. And we could get our x squared back in there. So x squared equals 8, or x squared equals 1. So our answers are going to be x equals plus or minus 2 root 2, or plus or minus 1. Okay, let's do some more. So on the back here we've got another negative exponent problem. Alright, for this one, I'm going to rewrite this as a to the negative second power, because 1 over a squared. I'm going to bring the 3 root 2 over. 3 root 2, a to the negative 1 power, plus 4 equals 0. Okay, now we can do my substitution. U equals a to the negative first. So I've got u squared minus 3 root 2 u plus 4 equals 0. Alright, this one I can't really factor. Alright, so I need to use the quadratic formula. So for this, right, I wouldn't even use u. I would just write it as 1 over a, or a to the negative first, equals, okay, negative b plus or minus the square root of b squared minus 4ac all over 2a, which is equal to 3 root 2 plus or minus root 2 all over 2. Alright, so since we have like terms on top, right, we want to actually get two answers. Don't leave the plus or minus in there. So we've got 3 root 2 plus root 2 is 4 root 2 over 2, which is just 2 root 2. And the second one is going to be 2 root 2 over 2, which is just root 2. Okay, remember this is 1 over a, so we need the inverses of both of those to get our actual answers. Okay, so to do the inverses of those, we're going to have 1 over 2 root 2. Let's just move it to the side here. Alright, so 1 over a is 2 root 2, so that means a equals 1 over 2 root 2. Multiply root 2 over root 2, and we're going to get equals root 2 over 4. And the other one, a equals 1 over root 2, just becomes root 2 over 2. So those are our two answers for that one. Now, of course, we need to check our answers. Oh, that's cool. It moves with me. Okay, so we could check our answers. They're not going to have any problems in the denominator being 0, so we're all good. Oh, I think I'm going to have to get rid of that one. I'm going to keep going. Okay, so number 6, we've got, this one is set up for us well. Okay, the only thing that's difficult is we've got a big substitution. We're substituting 2b plus 1 over b. And for us. So let's just make that u equals 2b plus 1 over b. Okay, so we've got u squared, bring everything else over, minus u minus 6 equals 0. See, it's easy to factor. U plus 2, u minus 3. Okay, so I can just automatically go to my two possible answers. We've got 2b plus 1 over b equals negative 2, or 2b plus 1 over b equals positive 3. Okay, we could solve this multiply the b over, add those. We're going to have 4b equals -1, so b equals -1/4. And on the right here, we'll have b equals 1. Alright, we need to make sure we plug these back in, so we're not going to have any problems. You're not going to have any zeros in the denominator, so you should be okay. And those are our two answers. Alright, 7 is one of those easier ones to recognize. Okay, you might not even have to necessarily do a substitution. I'm just going to do it anyway, though. So u equals x squared. So 4u squared plus 7u minus 36 equals 0. Alright, obviously check to see if we could factor this. I have a feeling we can factor it. 9 minus 4. I can't see it right after that, so I'm just going to go ahead and do the... Hold on. Okay, I see it. Okay, so we can factor it. We've got 4u. And u. Go to the plus 4 over here and minus 9 there. And that should work out well. Negative 36, we got 4u squared, we've got plus 16 minus 9, good, plus 7. Okay, so now we can get our x squareds back in here, and we're going to get 4x squared equals 9, or x squared equals -4. Okay, so the x squared equals -4 is just x equals plus or minus 2i. And the other one, we've got x equals plus or minus 3 over 2. So those are all of our answers. And the very last problem here. Okay, we've got one of the, just like the ones at the beginning. Okay, I'm going to do u equals root a. All right, make sure, since we have our square root of a, square root of our variable, we need to check for extraneous roots at the end. So we have 5u squared plus 6u plus 1 equals 0. Do some factoring. 5u plus 1, u plus 1. Okay, so we have 5 root a equals -1, and root a equals -1. Alright, so we've got a equals 1 over 25, or a equals 1. When you square both of those, so we got to check our answers. So in the first one, we'll have 1/5 plus 6/5. Let's see. 1/5 plus 6/5 plus 1 equals 0. That's not going to be very helpful. The second one, we'll have 5 plus 6 plus 1 equals 0. That's not going to be helpful either. So the answer is going to be no solution.